right, well, welcome everyone. My name is Fabian. I am the co-founder and CEO of KYVE Network. We're talk today about validating data in Web3. I'm a software developer, and I think I got into the crypto space in around quite early in 2020, probably, and then from there on, I was always active in the Riewe ecosystem. And then in February last year, we created KYVE Network. So basically, this talk, we're just going to quickly talk about what is KYVE, what are the problems we're solving. We're going to deep dive a little bit deeper into it with a small demo, and then just some quickly overview about like our roadmap and what has been happening, and at the end, just a quick Q&A session if there are any additional questions coming up. So one of the fundamental problems in the data space right now is basically that in a blockchain, data is very condensed, right? And especially on Ethereum as an example, there is no native way to query all data, for example, that lives on Uniswap. Right? You'd have to go through all transactions, find them. You can query events more easily, but in general, it's a big problem, right? And when you go even multi-chain, it gets even harder. And then how do you start connecting data from one chain with another, cross-chain bridges, right? It really gets more and more tricky because just the data is so much deep into the system because we have to optimize for data storage. I think if you guys are here, some smart contract developers, you know it really has become a state of the art, right, to make your smart contracts as storage efficient as possible. Well, why? Well, because you want to make sure that the whole system stays very scalable. And so that's also the reason why, for example, NFT metadata is not stored on chain. It's only for gas reasons. I mean, no one wants to pay $10,000, for example, minting. Well, some people do, but not the average person, right, wants to basically put that much money in just to have something on chain. And this is how storage solutions like Riewe came up. And yeah, another big problem are basically that then backups or snapshots of chains right now are mostly centralized and by this not reliable. Mostly talking here about node syncs, where if you're a node operator and you would like to join a new network which is already existing, what you have to do is you have to get either sync your node, but this takes months right now, if not even years, and it's going to just take ages. But what you usually do is you get yourself a snapshot that has been done by another node operator, so you need to trust him and then basically get this backup into your system. And then from there on, you're able, right, to run your node, bootstrap it, and make it accessible faster. And now the big question is, well, if we live in a completely trustless world, you cannot trust another node to get your data in. And we see this kind of thing happening a lot now. We're operating the Cosmos ecosystem, and we had the FMOS relaunch, right, where what happened is they had a state failure, and then they had no way to back up their old state because they didn't store it on chain and the new state was invalidated. So it was a big question for them, how do they go forward? And that's also something we are working on with KYVE. Another problem that's especially due to the Riewe ecosystem is there is no way to cache state transitioned. And what this means on Riewe, smart contracts are executed client-side, which means that every time you want to get the latest state of a contract, your client has to go through every state. And of course, now think about millions or billions of transactions. It's just not something your client really can do for basically on an everyday basis. And so this is also something we have built KYVE for. And then just in general, the cost of distribution for storage is expensive. The more decentralized your network is and the more data you accumulate, you need to really ensure that every node has at least most or all of the data. And then what's going to happen is, well, you pay more money, right, for maintaining your data storage infrastructure. And then the more money you pay, the lower your profit margin on running your node gets. And then at the end, it's only the big players that can basically afford having those crazy expensive infrastructures because they are the ones that still make a lot of profit with it. So at the end, it really leads to centralization if you're not careful with that on your network. And a big prominent example of this is actually Solana, where the Solana Foundation is one of the only, I know, public endpoints out there where you're able to get the full history of Solana because all other nodes have to delete the data after, I think on Serum it's like 7 days or something like that, just because otherwise it would be way too expensive for them to really handle all the history data access. And so basically this is the reason why we have built KYVE, and KYVE is a fully decentralized data lake. And the cool thing is that all the data that's stored through KYVE on Riewe is completely trustless. And we work with numerous L1s and other solutions out there. And the way it works, it's quite a nice concept. So we have a thing called a storage pool. And then basically the storage pool reads the data from one source and then validates it and then stores it on Riewe. And I can give a very nice example. So let's say we would archive Polkadot. So the storage pool for Polkadot would request Polkadot, hey, please give me block number 5 the node would get it, upload it to Arweave, and then propose to the other nodes in the network, hey, here is this piece of data, can you please check if it's true? And then the other nodes pull down the piece of data, run some validation logic against it. For example, well, does my local block is the same one than the block that the uploader has uploaded? If it's correct, they vote in favor of it, and if it's incorrect, they vote against it. And of course, if some data is found to be invalid, then the nodes get slashed, so no one is incentivized to ever upload invalid data. And then we only keep all valid votes on chain, basically meaning you have a backtrace, then you can really find all the validated data from a data source. And the data source can literally be anything. We're talking about blockchain archives, talking about financial data, because it's basically like an Oracle system, right? Just think about the Euro to USD pricing data and how many accounting databases this lives all around the world, right? But basically here, we can just save it in a single place because it's trustless, anyone is able to retrieve it, and then you can run analytics on it, you can make it available through indexes, you can make it cross-chain through services like Excella, and so on and so on. So I hope we can dive into a quick demo here, and I can show you what it looks like in practice. And let's hope the demo gods are on my side as well. Amazing. Thank you so much. So this right here is KYVE Network's page. We're right now in our testnet. We have an incentivized testnet running since April. And it's just some basic dashboard where you can see some bundles that got created, the total value log chart that unfortunately through an update got a bit wrecked, but it's still having all the correct data in there. And then here you can see we have those storage pools. There we go. Where we are archiving all those blockchains. Right here you can see the progress. So on Moonbeam we are already up at live data. Live data meaning that we have a maximum delay of 2 minutes. Well, just because the data has to be produced, right, it has to be sent to our nodes have to validate it. So whenever you work with KYVE, you will always have, right now, a delay of up to 2 minutes. So when we click on it, here, you can see an overview. You see how many KYVE got logged, how much data we archived, how much bundles got created. And then here in the validator section, you see the nodes, basically their API. So it's a proof of stake system also on the chain level and on the protocol level. So you can delegate your tokens, stake your tokens, and better secure the network. And actually here in the overview, which is quite nice, you see the live position of that bundle, if it got created, when the voting is ended, if this one is going to time out or not. And basically, yeah, we have a bunch of storage pools for all the, there we go, for all the different networks we support right now. Writing your integration is something that a developer can just do on the spot. We basically provide a library from our side, and the only thing you would have to provide from the counterparty is one function where you describe how to fetch blocks or data and how to validate it. So our built-in validation function is just a hash function saying, well, does my uploaded data equal my local data? But let's say on pricing information, you might fetch from different exchanges, so the price will not be 100% equal. So you can write your own validation function, making sure that the data is like almost the same, and so on and so on. So we try to make it really customizable. And then we also have fully decentralized network, meaning that all of our decisions are happening through our governance proposals. So if you would like to create a pool or create your own runtime, change network parameters, you can just submit a proposal and the community will vote on that. The KYVE chain logic lives on the Cosmos SDK chain. We've actually been through quite some tech odysseys. So we started out being fully Arweave based and then realized actually Arweave smart contracts aren't production ready enough to the extent that we needed them. Then we transitioned over being an EVM based contract, storing the data on Arweave. And then we went into this really nice EVM problem where it was during the bull market and just gas prices were crazy expensive, right? Because you have to share the block space with all other applications living on Ethereum, and that's really leading to the problem that, well, on Uniswap, if you make a 10K profit swap, you're fine with paying $300 in gas, right? But not every transaction on KYVE really has this economic value, so we had to find out a different solution for solving that. And even we deployed it on Moonbeam actually, and even there we were facing those problems. And then what we did in, I think February, we migrated the logic over into a Cosmos-based SDK, and it's running quite successful, quite good as of right now. And yeah, we are going to hopefully launch our mainnet beginning of Q4 this year. So this is the incentivized testnet. It was separated in 2 phases. One phase was very social-driven, and the other one was very tech-driven. We tried to kind of really include everyone in our community. And I think at the end right now we're ending up with 71, maybe 80,000 active users. Let's see. 0, nice. All right, that's the demo gods I talked about. I think it's around 70 or 80,000 users we had being active on the chain, but active users including users that really like delegated, staked, ran a node, and so on. Oh, there we go. Unique users, nodes running 2,000. Basically mean we have 2,000 nodes running in total on that. And yeah, let me just jump back into the presentation. Is it on here? Yes. Perfect. And then awesome. Yeah, as I said, KYVE actually started as a bounty project. I think it was me and John just browsing through Gitcoin one day and then sawing a bounty from Parity and Arweave, which was, well, please find a solution that archives Polkadot on Arweave. And we were, oh, that sounds like a cool weekend project. So we got started on this and then got some very cool feedback from Parity, from the Arweave community, and then we started reaching out to, well, all the other layer ones, so like Cosmos, Avalanche, Near, Solana in the beginning, the graph as well for indexing purposes. This is how the whole KYVE project got seeded in the beginning and how we got started. Then, as I said, we've been through quite the tech journey with different testnets on Arweave, on Moonbeam, and now finally settling on Cosmos. And now, really, the next big step is just preparing everything for mainnet. We're going to launch some bug bounty programs, some feature programs to really just kind of like drive that, building out some new use cases and really like fine-tuning our governance processes. And then hopefully, if everything goes smooth, to set the mainnet launch beginning of Q4 this year. As already said, those are some of the partners we have already integrated with, all of them facing their own problems, but most of them facing the same problem at its core level. Just to go over some above, so on Avalanche, a nice use case we have there is a node operator actually syncing his state through KYVE on Arweave, and then being able, in case of failure, just go to KYVE and load the data in from there. On Solana, I already said we are archiving them. But Solana it's a big challenge even for us coming up. But basically on Solana, it's just that they produce so much data and they have really kind of like trouble providing the infrastructure for it being able to query it. And they only like, what now, maybe now like 2 years old at max, and like it's already starting to facing scalability problems. So that's something we try to do, because once we have archived block 0 from Solana on KYVE, they can safely delete it. Because you always know you can always safely retrieve block 0 in case anything goes wrong. You can load it into your indexing system. It just gives you more flexibility. And then for stacks, we actually built with them. I think since they launched, we had an integration up and running with them for archiving purposes. And then also now with all the Cosmos ecosystems and all the EVM ecosystems coming in, we also announced a little sub-project called Warp. And Warp is a GraphQL indexer on top of KYVE. You can go to warp.kyve.network if you want to see what it looks like. And it basically allows you to query data cross-chain, because we have all this data stored, and we know what the data looks like when we store it. So basically what you can do, you have one endpoint, you can put in your address, and you can say, well, what does this and this address has made on, for example, Avalanche and Ethereum? This is how you will get your results for it. It's very useful for like any cross-chain interactions you have. And just last, I want to jump into a quick Q&A session if there are any questions coming up. I'm also available all day if there's anything else.
So you're not doing anything with like custom indexing or custom processing of events, like if I'm making a subgraph. This is just purely indexing the data from different chains. Is that correct?
Exactly. So we are just purely storing and validating this data. And if you were building like an indexing service, right, you wouldn't have to worry about how do I run my full node, how do I connect to my archival node. You can really just go to KYVE, get the data into your system once, and you're good to go, right? Actually, I saw also Quill on the presentation before that. Actually, Quill is an SQL service that also uses KYVE data and then gives SQL access basically to developers that would like to get SQL access to data that's usually not available in that form. Exactly.
And maybe a follow-up question on the last point you made. So does that mean because you mentioned that KYVE is essentially a data lake for this data, index data. So does that mean that I can use like just RPC to get that data, or is there like a REST API that I can fetch the data with?
So there is, so basically the way it works is that we on-chain store the reference to the data being stored on permanent storage, so on Arweave, right? But there, of course, it's compressed. So what you would do is you would request our REST API at KYVE and just say, hey, either give me all valid bundles from this chain and you can fetch them on your own, right? Or we also have like one indexed endpoint where we can say, oh, please give me the block height, and then we point you to the right Arweave transaction where the data is in. But of course, you would have to do all the like decoupling and like aggregation, whatever, on your own. And that's why we really kind of like see now use cases being built on top of KYVE that make this querying easier for you, right? And then that's also, I didn't think I skipped over that part a bit too fast. We have a funding mechanism for a pool. So a pool always requires funding. And if a pool would run out of funding, it would pause and not produce or archive any more data, right? This is the main incentive mechanism behind KYVE. So let's say you want to build an indexing solution that uses KYVE data, then of course you would be always incentivized, right, to keep the pool in funding and ensuring that the data that we produce is then stored in your system. That's the main idea behind it.
Any other questions? Okay.
Thanks,
Thanks, Fabian.
Thank you.